All right, this handout is asking you to construct a graph, and I'm going to kind of do a little bit of graph and explain in general what things should look like. The graph paper you have should be enough space for you to graph all the things that you have on here. First couple things to point out, and I'm going to do a little mini graph over here on the side, is in terms of labeling it, all right, because it does tell you how to label things up here. So you're going to have your graph. And this being a line graph, you need to have time across the bottom and you need to have temperature on the y-axis. You don't need to label every single increment that is on here because you're going to run out of space with that. So again, time goes up to 25. So if you want to try to label it every minute, if you want to label it every 2 minutes, if you want to label it every 5 minutes, that's up to you. But just remember, as you label things, they should be equally spaced out. The same thing with temperature. Temperature starts at -20 and goes up to over 100. So you need to start with -20 on the temperature scale. And you don't want to graph all the numbers that are on here. What you want to do is graph an equal scaling. So with this one, you may go up by units of 10. That's probably what I would do. So I would set the graph up to be like -20, -10, 0, 10, and so forth. And then plot the dots as you do that. So then again, at time 0, you put a dot for 20. At next one, next little half minute over, you go to 0.11. Or the other thing you might do to make sure you get things in the right place is if these are if you do these 5, 10, 15, or 2, 4, 6, 8, whatever it is, make sure that you graph those accurately, and then you can kind of work your way back. Again, this doesn't have to be a perfect looking graph. Once you get the graph done, it's going to have a general shape like this. It's going to go up. It's going to have a plateau. That should be a plateau. It's going to go up. It's going to have a plateau, and it's going to go up again. All right, so when we have an object and it goes from a solid state to a gaseous state, it's going to experience some changes. So remember, what's happening is the temperature is going up when we go through here. If this was water, basically what we've got going on here is this is where you've got ice, this is where you've got water, and this would be where you have your vapor. You'll notice in those places we have a line that's got a positive slope to it, and that means during those times the temperature is actually increasing. You've also got these other two flat places where the graph is not increasing. And so this is when we get a phase change. So one thing changing to another one. So in this case, we've got ice turning into water if you're reading it from left to right. So this is where melting would occur. And then from up here, we've got the water turning into vapor. So this is where vaporization or evaporation would occur. So we can read our graph and be able to indicate a number of different things on it in terms of where things are happening. So as it goes up again, I've got solid ice. It's getting warmer and warmer. It's still ice. When it starts here, that ice is melting. So you've kind of got a combination of ice and water. Once all the ice has melted and you've got water, then the temperature will start increasing again. And it will do that until the water reaches the vaporization point. And at the vaporization point, all the water doesn't evaporate at once. You've boiled stuff on the stove. You probably have seen this. It takes a while. So as time passes, the energy that's going into it is changing the water into gas. So in this flat line, again, you've got kind of a combination of liquid and gas until it gets to the point where everything is boiled off. In our kitchen, we usually don't see this part because this would be all vapor. But if we had a way to contain it, then at this point, we could continue increasing the temperature of the gas that was on there. So if you labeled this, again, this is your solid, this is your liquid, this is your gas. This is going to be our melting point. This is going to be our vaporization point. Now, if we were going backwards, this would still be a gas, this would still be a vapor, and this would still be a solid. But when a gas, it's not a vapor, this liquid. When a gas is turning into a liquid, all right, that's going to be condensation. If we're going in the opposite direction. And then when our liquid turns into a solid, you might know that as freezing. And those are going to occur on the same plateau. So this plateau right here, depending on if you're reading it from left to right, when it's getting hotter, could be melting, or if you're reading it from right to left, could be freezing. Same thing about this plateau here. If you're reading it from left to right, that means it's getting hotter. That means we're vaporizing. If you're reading it backwards, if it was flipped around and cooling off, then that's when condensation would be happening. That's when gases would be turning into a liquid. Okay. We could also use this graph to talk about energy, because in a weird way, even though would be heating it up the entire time, it's only in a handful of places where the temperature is going up. So when the temperature is going up, remember that if there's an increase in temperature, there is an increase in kinetic energy. So there are 3 places where the kinetic energy is increasing. So at this point, the kinetic energy is going up. At that point, this line, the kinetic energy is going up. And this line, the kinetic energy is going up. There's 2 places again where we add energy, but the temperature does not increase. And in those places where the temperature is not increasing, we don't get an increase of kinetic energy, but we're still adding energy. So what's actually happening is we're getting an increase in potential energy. So when the temperature doesn't change, we're getting more potential energy, but there's no change in kinetic energy. So in order for kinetic energy to increase, we also have to see a temperature change. And the way we see that on the graph is the line has to be going upward for that to end up occurring. Now, the last things that we can do with this is we can infer the melting point, freezing point, all those types of things, because again, remember those flat lines, that's a phase change. So the first flat line is where melting occurs or freezing occurs, which means if you come over to the y-axis, that would be the point on the graph in which this thing was melting or freezing. And then when you come to the second flat line on the graph, that's either going to be where your boiling or evaporation is occurring, or you're going to have condensation. And again, if you come over and read your graph, you can figure out what temperature that would end up being on there. So hopefully that would help you to answer most of the questions that you have on here if you go back and look at them. There's a couple of questions here at the end about how long does it take. You can just read your graph. How long does it take? Read your graph. Does temperature change during a phase change? Remember, the phase change is the flat parts. 11, how can you figure out the amount of heat absorbed or released? I'm not asking you to do this, but you'd use your formula. Q equals M times C times delta T. So you would need to know how much water you've got. You need to know your specific heat of the water, and you need to know your temperature change. And then you could determine the Q value for that. So on number 12, it says, let's find the heat in joules released if you have 35 grams of water, which is your mass. The specific heat of water is 4.184. All right, and then it says as it passes through region C, if you label things appropriately, region C is going to be as it goes from 0 to 100, which means your temperature change should be about 100 degrees for that. Right. So you're solving for Q. There's your M. There's your C. There's your change in temperature. And all I really need to do is to multiply those together to get your answer on that one.